We will start the session right now. Okay, today we will be starting with belt drive. We have started machine design 2 with gear drive. For power transmission, we use gear drive when a large amount of power need to be transmitted. Uh, but the transmission input and output shafts are very close in case of gear drive. So there are the applications wherein the input shaft and output shaft are at far distances. So to connect input and output shaft, you need to use the element. There you cannot use gears because then the number of gears required and the size of the gear required will be very large there. So in such cases, the input and output shafts are connected with the help of flexible elements. So various types of flexible elements are used. So one such flexible element is belt. That is, you can have flat belt, V belt, even you can use rope for power transmission also. Even you can use chain. Chain as such, individual link is not flexible, but when you take number of links together and join these links in the form of a series, then that chain form becomes a flexible link. So flexible element. So chain drive also comes under flexible drive. So there are various types of drive used to transmit power from your one input shaft and output shaft, which are at a far distance. So the distance may range from say 200 mm to maybe up to 10 meter or even 20 meters, depending upon the requirement. So uh, we are going to start with the basics today, basics of belt drive mechanism here. So let's go to the what are the flexible drives available are used here in the market. Okay, so we are learning starting today the belt drive. So let's understand what are the different types of belt drive. So different types of belt drive are flat belt drive, in which we will have two pulleys, basically maybe flat pulley, on which an endless element that belt will be mounted so that you can transmit power from one shaft to the another shaft by moving this belt over this two pulley. So this is an flat belt drive. So similarly, you can have a V belt drive. Here, V belts are there, and this is the V pulley. So associated belt and associated pulleys will be used. So this is V belt drive. So when you want to transmit a large amount of power with minimum slip, here there is a chances of slip, but here the slip will be reduced. So to minimize the slip and to transmit high power, we can go for the V belt drive. Then you can have your belt, either a flat belt or V belt, on which at the bottom side of that belt you will have serration. That is a toothed belt. You can say tooth belt, and the pulleys used will have similar serration. So it's like a gear. So you will have small gears having say a very small module value will be used, driver and driven gear, and these are connected with the help of toothed belt. So such arrangement is called as toothed belt drive. So of your work.
Hello, sir.
Listen to you or not? Hello. If this if this is your driver pulley and this is your driven pulley, say input shaft and output shaft, then in this case there will be speed increase from input to output shaft. So driver these pulleys will be used either for speed increase or speed decrease depending upon the size. So let's go for the detailing of flat belt drive. Let's go to the next slide. So we are now learning flat belt arrangement and the associated terms. So we'll have say two pulleys here. They having bigger pulley diameter and smaller pulley diameter. So let's say bigger pulley diameter is a capital D and the smaller pulley diameter is a say small d. So you can wrap your belt around this pulley surface, both the pulley surface. So these pulleys say separated by distance x or say center distance say capital C here. This value is say capital C. This diameter is capital D, this diameter is small d. So such arrangement is called as open belt drive. So in this, when you rotate this say pulley in this direction, say clockwise direction, so belt will move from say left to right here, and this belt side will move from right to left. So this will cause this pulley to rotate again in clockwise direction. So open belt drive. So you will maintain the input and output shaft same direction. So such arrangement is called as open belt drive. You can have in the flat belt arrangement cross belt drive. Cross belt drive means what? You will have bigger pulley diameter say capital D, smaller pulley diameter small d, and center distance say capital C here. So in this case, your belt will be wrapped around bigger pulley and smaller pulley. So such that, so if you can see this pulley is, belt is coming here, then it is wrapped in a reverse manner on the other pulley. Say this is wrapped in say forward manner. So when it comes to the wrapping of this belt on the smaller pulley here, it is wrapped in the reverse direction, so in a backward direction. So this arrangement is called as cross belt drive. Now if you see here, if this pulley is rotating clockwise, so this belt will move forward here. So this belt will ride here. So this belt will cause this pulley to move in the anti-clockwise direction. So this is a clockwise direction, anti-clockwise direction. So cross belt drives are used when you desire input and output speed, output rotation, they should be opposite to each other. So these are the basic two types of your flat belt drive mechanism: open belt drive mechanism and cross belt drive mechanism. So in these cases, the shaft 1 and shaft 2, they are parallel to each other. In both the cases, the shaft axes are parallel to each other. Uh, Another type, that is, you can have shaft axis here perpendicular and shaft axis here is in this plane, vertical plane here. So this is a horizontal shaft and this is a vertical shaft. Now you are mounting one pulley on this shaft and another pulley on this shaft. If you want to connect this pulleys with the help of wrapping the belt, then the arrangement is called as cotton turn belt drive. This arrangement is cotton turn belt drive. So such type of arrangement you may have seen visited the old flour mill, which wheat flour mill or say rice flour mill. So in this old flour mill arrangement, you will normally see this type of arrangement wherein the flour mill will be vertical device. So the pulley of that flour mill will be at the bottom, and there is a driving shaft which will be driving multiple machines. So which will be horizontal and which will be driven by a single motor, big motor, or maybe by engine also. If it is very old, then it will be run by engine. So to join these two arrangements, the belt mechanism is flat belt mechanism is used such that then you can make a quarter turn of your belt. So this is called quarter turn belt drive. So this is The angle of contact will be done for smaller pulley. So that I am explaining in the next slide also. So you can understand that. Okay. So now this that formula also I have given here. Arc of contact on smaller pulley. There is arc of contact is equal to theta is equal to, since it is less than 180 degree normally. So theta is equal to 180 degree minus d minus d, which is into the bracket, upon capital C into 60 degree. So this formula is taken from 7.54, but actual theoretical formula is slightly different. There are the sine terms involved in it, sine inverse term is involved in it. But when the angle, if this center distance here, if this center distance C, that this distance is very very large, that sine can be replaced by a normal angle here, theta angle here, theta in radian. So that's why the corrected formula used in the PhD is this 180 degree minus d minus c upon c into 60 degree. So this is the angle of contact, and you need to maintain on this small theta need to be measured on smaller pulley, because this is very important from the power transmission point of view. So when we want to transfer power, so now let's understand how this power is transmitted from say pulley A to pulley B. So you will have say pulley is rotating say clockwise, say driver pulley, and pulley B is say since it is open belt drive, so pulley B will also rotate clockwise, and it is called as a driven pulley. So when this belt is moving on this surface here, it will be experiencing the tension. So it will be experiencing different tensions in the different sides. So this side is called as the tight side, and this side of the belt is called as the slack side. It is called as the slack side. So what happens when I have drawn the free body diagram also, so that you can understand there. So this is the tension side, tight side of the belt, and this is the say slack side of the belt. So we are assuming the tension in the tight side of the belt is say T1, and tension in the slack side say T2. So if you take a very small element of the belt here, very small element of the belt with angle d theta, then so this belt will be subjected to tension T, and say other end of the, delta theta T plus delta T. At the same time, this belt is moving, so it has a relative motion with respect to this surface of the pulley. So so there will be a chances of frictional force developed there. There will be chances of frictional force, and that will be directly proportional to the normal reaction R here. So frictional force F is equal to mu into R. So what happens if you write down the equilibrium of these forces? If you write down the equilibrium of the forces, and if you want to transmit a power, so necessarily in the equilibrium condition, so this body should be in non-equilibrium condition. Then only the power will be transmitted. So to maintain that non-equilibrium, we need to have this tension on the tight side slightly greater than tension on the slack side. So there should be a difference between T1 and T2. Then only power will be transmitted. Otherwise, the power will not be transmitted. So belt tension, so T1 belt tension on the tight side, T2 belt tension on the slack side. Angle of contact considered while doing this calculation here. So that is equal to theta 180 degree minus d minus t upon c into 60 degree. then the belt speed, so this belt is moving with a speed. So assuming there is no slip between the pulley and the belt, assuming that so pulley speed at that surface will be equal to the belt speed. So the belt speed can be written. You can write either with the help of bigger pulley diameter or with the help of say smaller pulley diameter. So if you are writing with a bigger pulley diameter, then it will be pi d n1 upon 60, where n1 is the speed of this bigger pulley diameter. Or it can be pi small d into n2 upon 60, where n2 is the speed of your smaller pulley. Okay, so n1 is the speed of bigger pulley, n2 is the speed of smaller pulley. Now, so the power transmitted will be based on the tension in the tight side and tension in the slack side. So power will be equal to here T1 minus T2, the tension difference between the tight side and slack side, into the velocity. So if T1 and T2, if we take in Newton and velocity in meter per second, so you will get the power transmitted here in watt. Okay. So uh, for better power transmission, you need to have this T1 and T2 correctly. So how will you adjust this T1 and T2? So to adjust this tension in the tight side and slack side, you need to use the belt having shorter length. In the previous slide, we have seen the calculation of the length of the belt. This is the formula for your open drive. This is the formula for cross belt drive, and this is the formula for your concentrator drive. But these are the theoretical lengths. Now, when you are want a right power transmission, proper power transmission, then T1 and T2 has to be appropriate. So to maintain the value of T1 and T2 appropriately, correct initial tension, this is very important. Correct initial tension is obtained by using belts of shorter in length. So you have to make your belt length shorter than the theoretically required. So actual length of the belt used while mounting on the pulley will be less than the theoretical length. So how much shorter we have to make, that will depend upon the number of plies used in the belt. So the belt may be made up of single ply, 2 ply, 3 ply, 4 ply, 5 ply, 6 ply, multiply in nature. So depending upon the you need the cross-sectional area requirement as well as the power need to be transmitted. Your number of plies will be used, and how much shorter you have to make, that will be decided by the number of plies. So normally it will be shortened by 1 to 2.5% depending upon the number of plies there. So if you required say 1000 millimeter length as the theoretical length, and if you want to create a tension in the belt properly, then suppose it has to be reduced by 1%, then 1000, 1% of 1000. So you need to use the belt length exactly of 990 mm instead of 1000 mm. Then only you will have this power transmission proper. Again, there is a relation between T1 and T2. Tension on the tight side and tension on the T side. So T1 by T2 is equal to E raised to mu theta, where mu is the coefficient of friction between the belt material and the pulley surface, and theta is the angle of contact, and that theta is nothing but the angle of contact on smaller pulley. That is the smallest angle. Don't take the angle of contact on the bigger pulley, then your calculation for power transmission will be wrong, because you will express T1 in terms of T2 and you will do this calculation. So based on the power, you require to maintain tension, and that tension value need to be sustained by the belt. Otherwise, either belt will slip. If the excessive tension is there, there is a chance your belt may break also. So the belts are selected such that they should sustain that the tension force. Now this is the belt force analysis, that is tension in the belt. Now since this belt is moving at a certain radius along a circumferential manner, it is moving along a circumference here. So it is going to experience a centrifugal force. So belt material also going to experience the centrifugal force. So that I am explaining in the next diagram. You can see here centrifugal tension in the belt. So what is mean by centrifugal tension in the belt? Please understand here. So this is a small a pulley on which a belt is wrapped here and which is moving. Let's consider a very small element of this belt having d theta angle here. So this belt will be subjected to because this belt is uh, along this circumferential path. So it has a very small mass. So the centrifugal force will be 1 by 2 mv square. So the centrifugal force will act radially outward. So this is the centrifugal force acting on that belt element radially outward. Now these force need to be balanced. This is an unbalanced force. So this force needs to be balanced. So this force will be balanced by belt tension on the both the side of the belt, either both side as well as right your slack side. So this belt tension, additional belt tension, is called as centrifugal tension. So this value, to balance this force Fc, you need to have a tension, additional tension in the belt. So that tension is called as centrifugal tension. So centrifugal force acting on the belt will try to throw the belt away from the pulley. So that I explained right now. There is by it produces a tension called centrifugal tension. So it produces a force value tension Tc. So to determine Tc, you can write down the formula for Fc. Formula for Fc, that is your centrifugal force is equal to mv square by r into the length here is r d theta. So into r d theta, r will get cancelled out. So centrifugal force of that small element is equal to mv square by d theta. Now this force can be by using this tension value in the belt can be resolved into vertical direction. Say let's say resolving this forces, writing equilibrium in vertical direction. So that it is written here, resolving the tensions in radial.
Hello, sir. Hello. Hello, sir. You are not audible.
Hello. Hello. I think it is audible now.
Yes, sir.
Yeah. Now, this is the basic and preliminary analysis we need to use while starting the design. Understanding the various tensions in the belt, uh, tight side tension, slack side tension, centrifugal tension. There is a relation between centrifugal tension and T1. The centrifugal tension should not be greater than one third of T1. Otherwise, then the design belt may slip and the belt may lose the contact because the basic effect of centrifugal force is throw away the belt from the surface. So it will lose the contact here. As it loses the contact, then the slip will happen here. So that is very important. Now, how to use this belt with pulley? So what are the different types of pulley? Let's understand the different types of pulley available here. So this is very old concept. Most of the old industries and the floor mills, you will find such pulley. So this is a block of two pulleys, and which is called as fast and loose pulley. What is meant by fast and loose pulley? So the pulley on which these two pulleys are mounted on single shaft. One pulley is called fast pulley. So here the left side pulley is fast pulley, and the right side is pulley is loose pulley. What is meant by loose pulley? It is free to rotate on the shaft, but it will not rotate the shaft. The meaning of loose pulley, it is free to rotate on the shaft, but it will not rotate the shaft. That is the meaning of loose pulley. And the meaning of fast pulley, it is not free to rotate on the shaft. As it rotates, it will rotate the shaft. So if you see the arrangement of the fast pulley, this fast pulley is connected to the shaft with the help of a key. You can see this is the give head key mounted here. So this hub of this pulley is connected to the shaft with the help of key. So when you rotate this pulley, the shaft will rotate. Or when the shaft is rotating, this pulley will also rotate. But in case of loose pulley, if you see here the mounting mechanism for loose pulley here, you will have hub. Then this is the shaft. In between hub and shaft, you will find another element. So this element is called as bearing. So you will have a liner mounted here, so which will be fixed on the shaft. So the pulley is mounted on this liner, which is free to rotate on this liner. So when this pulley is rotating, the shaft will not rotate. Or when the shaft is rotating, this pulley need not necessary to rotate because there is a gap here, clearance gap here, and there is no positive engagement. So this pulley will not rotate. So that's why this pulley is called loose pulley. This pulley is called fast pulley. Now, what is the use of this pulley, fast and loose pulley assembly? When you want to engage a power from a driver to driven, that is driver shaft to the say machine shaft or driven shaft. So this block of assembly is mounted on the driver shaft. Okay, so which is connected to the either engine or say motor. So, but you there are the other devices also run by that engine or motor. So you don't want to stop that engine or motor. So, but you don't one particular machine you want to stop. So what you have to do? The belt mounted on this fast pulley just tipped on the loose pulley. So the power transmission from the input shaft to the output shaft will be stopped. But the input shaft will not stop rotating. It will be further rotating, but it will not transmit the power. Then your machine requires the engagement. So then what you can do? The pulley on the loose the belt on the loose pulley will be shifted to the fast pulley. So there will be a belt shifter mechanism. So you can shift pulley belt from fast pulley to loose pulley and vice versa. So that will facilitate without shutting down of the engine or without closing down of your this thing. You can stop your machine. Even you can maintain the if the belt need to be properly tensioned, you can maintain the belt and you can once the tension is adjusted, you can use it. So this is very important concept called fast and loose pulley. Nowadays it is very rarely used because nowadays individual machines will have individual drives. There was no common rail mechanism, common rail drive mechanism. Earlier they used to have. So such mechanisms are now very rarely used, but still you will find in some of the application fast and loose pulley. So when you are designing belt drive, so you need to select the right pulley, right size pulley. Then design consideration for pulley will also come into the picture. So my next slide talks about the types of pulleys used in the belt drive mechanism. So these are the various types of pulley. So say this is your open drive. So there is a say tension. So what happens? There is a slack side and this thing. After usage of your belt, even though you use your belt shorter in length than the design length, after usage for 1 month, 2 months, 6 months, your belt is happens to, since it is a flexible material, belt happens to elongate. So what will happen? So it will increase the slack on the slack in the belt more. So that will then that will decrease the belt tension. So as the belt tension decreases, then power will not be transmitted properly. So to maintain the belt tension, what we can use idler pulley, and we can push this belt by some angle. So this will help you to maintain higher tension in the belt, as well as since you can use this idler such that it can be closer to the smaller pulley. So this will increase the angle of contact on your smaller pulley. So idler pulley will help to increase the tension as well as to increase the angle of contact on the smaller pulley. So that T1 by T2 raised to e raised to mu theta, that theta value will also increase and better power transmission can be done. So in the open belt drive, it is not necessarily only two pulleys are used. You may find maybe additional idler pulleys depending upon the length of the center distance and the length of the belt will be used. The idler pulleys may be used on both sides, here as well as here also, or they may be used in multiple number depending upon the length. If the distance between two pulleys is very large there, then instead of going for one idler pulley, you need idler pulley concept is important. Now, when you are select to decide the geometry, shape, and the constructional detail of the pulley, so this is an this type or block type pulley, maybe made up of cast iron material or maybe cast steel material. So you can directly, it is an integral material. This is the block having a greater thickness, or you can have same thickness everywhere, here as well as here, same thickness. This is called block or disc pulley. Then pulley with rib and rim. So this is having say bigger diameter. This pulley will be bigger than this pulley diameter. It will be bigger here. Then we will have a hub and this rim. This is the rim. The hub and rim will be connected by rib. So the rib mechanism will be there. Now to reduce the weight of the pulley, they may have holes, but they should not hamper too much. The holes will be provided such that they will not hamper the strength of the object, but they will reduce the weight. So they may be used to reduce the weight. So rib and rim type pulley will be used once the diameter is increasing. So again, this may be of your cast iron material as well as steel material. Nowadays, the pulleys, aluminum pulleys are also being used to some extent. Then, if the diameter is very, very large, then you can go for cast iron or say steel pulley having arms or say spokes. So pulley with arm or spoke. So number of arms will depend upon the number of size of this pulley. If pulley diameter is smaller, then you can use 3 to 4 arms. If your pulley diameter is very big, then you can use your number of pulley arms around 8 to 12, depending upon. Again, this number of arms now here it is only single row is there, single row. But if your pulley width is more, this width of the rim is very large, required width is large because belt width is also large, then you require bigger width. Then in that case, you can use the double row of arm. So instead of using single row of arm, double row of arm also can be used. So this is integral part. Hub, even your arm and rim, they are made up of same material. But if your diameter is very, very big and you want to make your design safe and economical, then you can go for split type pulley. So in which this material will be different, this material will be different, and this material can be different. So what they have done, you can take a steel plate, you can bend that steel plate, then you can take steel spokes here and weld together. You can take the arm, then you can use the bolting mechanism here. So this pulley is made up of two parts. This part is separate and this part is separate. Even bigger pulley diameters can be made up of 3 elements, 4 elements, up to 6 elements. They can be made up of. So very large pulleys will be manufactured with the help of split mechanism. They will be used in the split, and basically these elements are either of steel material. They are not of cast iron material. Please remember, split type pulley will not be cast iron material. Cast iron material pulley will be a solid pulley having same material everywhere. This pulley will be made up of only steel material. So when we are designing or selecting pulley, so we need to determine what should be the size here, arm size here. Again, the cross section here may be a rectangular cross section or maybe elliptical cross section or maybe circular cross section, depending upon the type of arm or spoke we are using. Here I have shown elliptical cross section. Here I have shown tapered rectangular cross section. Tapered means what? The cross section on this side is small, cross section area on this side is bigger here. So this is a tapered rectangular cross section. This may be tapered elliptical cross section or same cross sectional area can be used. So depending upon this, we need to determine the size of this cross sectional requirement depending upon the number of arms. So that will be also given in the PhD data book. So when we will be solving actual problem, so that time either we will take cast iron pulley and design accordingly, or we will take steel pulley and design accordingly. So the basic requirement, the calculation of length, and this is very important. So there are two types of materials used for the belt having a different density. Polyterranean material is used having varying density values. Again, number of plies, this is very important. Now you may ask, so what is meant by ply? Ply means you are taking a fabric material for the manufacturing of belt. Then number of such fabrics are taken. Layer by layer fabrics are mounted together, and the required thickness is obtained. So if you take one fabric, so it will be called as one ply. If you take say 5 such fabrics and you glue together, then it becomes a 5-ply system. It becomes a 5-ply system. I can show the ply system in PhD given here. So you can understand that. Here you can see it. Okay. So normally fabric belting, you can have high speed category or port category. So high speed category will have approximately the density of the order of 878 gram per meter square cross sectional area. Uh, and Dunlop type port. So this is Dunlop is a manufacturer of net belt. So they have two categories of material. One is high speed material and another is port material. So this they will have density difference here. So weight difference here. So based on that, these materials will be used, and you can have 3-ply system, 4-ply system, 5-ply system, 6-ply system, or 8-ply system, and these they will have standard width. So these are the standard widths available for these ply systems here. So we will determine how much standard width will be required based on our power rating. So in this case, what is the then ply size? No, ply size is not fixed. It varies from 0.7 millimeter. One ply thickness may be 0.7 millimeter up to 5 millimeter, depending upon the way the fabric is integrated there. So it is no standard value. There is no formula. One ply is equal to this much thickness. No, it is not like that. So they will the manufacturer will supply this. This is my 5-ply system having this much power rating. A single ply of this system has this much power rating. What is your, suppose it is having say 0.25 kilowatt per ply, then he will say what is the your power transmission requirement, say 20 kilowatt. So 20 kilowatt. So this is my 0.25 kilowatt for say 10 millimeter of width. I am having a ply of say 100 mm. So 0.25 into 10 means if you use single ply, then it will be 2.5 kilowatt. Now you want to transmit how many? Say 20 kilowatt. So you require 8-ply system there. Then you require same material of 8-ply system having 100 mm width. So 100 mm width. So this is the standard width available. So you can use 6-ply system or 8-ply system for that, and you can use that belt for your application to transmit that 20 kilowatt. So all that calculation we are going to do in a problem. So we are going to use this data, entire data. This is the PhD data. I have scanned and uploaded. I will upload in classroom also. So I told about correct initial tension, the belt tension. You have to use shorter length than the actual. So shorter length, if your belt ply, then you can decrease the length by 1.5%. Or you can 4-ply, 5-ply or 6-ply system, you can decrease the length by 1%. And 8-ply system, you can decrease only by 0.5%. So all this data is given. So you need to do the calculation properly. Then load correction factor, you need to, based on your application, you need to correct your load. Then arc of contact factor, arc of contact. If your angle is less than 180, then your arc of contact factor will be changing. So there will be a correction factor for arc of contact factor. Then based on your high speed or port requirement, you can determine the ply and you can design. So I am going to explain this thing again when actual problem you will be solving. So that time I am explaining this concept. This is slightly complicated concept. So I'll explain with the application, with the problem. Then you will have tolerances. Okay. So there will be a pulley. I have shown fast and loose pulley, and you have seen there is a one the top surface, and there is a decrease on this side. So this edge height is called as a crown height. This is called crowning of the pulley. So pulley may be having flat surface or maybe crown surface. Crown surface is very important when you are having larger diameter of the pulley. If your pulley diameter is not large, then axial thrust on the belt will cause the belt to slip from that pulley surface. And if you are having crown surface, there is a very less chances of slipping of the belt from the pulley diameter. So if your pulley diameter is big, then you need to provide a proper value of crown. So there is a table available for it. So you can see the crowning, how much crowning effect has to be provided. So crown height h in terms of pulley diameter. So if your diameter is increasing, then naturally your crown height is also increasing based on your pulley width. Width is also important. So crown height will depend upon pulley diameter as well as the width of the pulley. So this crown height is very important. If you don't have crown, then there is a chances of slipping of the belt from the pulley surface. So to avoid slipping of the belt from the pulley surface, side slipping, it is to avoid the side slipping, crowning of the belt is very essential. And normally this pulley width, this is the pulley width, your belt width will be this much and your pulley width will be at least 50 to 30 greater than the belt width. So when we are selecting pulley, your pulley belt width is the deciding factor for selecting the pulley width. So these tables are given. So based on these tables, the pulley diameter, pulley width can be selected, crown also can be selected. And now then there is a small calculation, cast iron pulley, then the size calculation, what should be this cross-sectional area calculation. For this pulley arrangement, it is shown here. So a small pulley diameter. So what will be the size of the based on this thing. This is again proportion. There is no stress calculation. It is just size calculation based on the given geometry for given diameter. So there is no stress calculation in this chapter. There is basically these values are experimental values or formulas are there. So these formulas can be used. This is the steel pulley that I told. This steel pulley can be made up from a number of parts. This is a split pulley. If your diameter is bigger, then you can go for split. So then the diameter of the spoke is very important. Size of the spoke. So number of spokes. When the diameter is this much, then what should be the number of spokes? What should be the standard size of spokes? These are the standard size of the spokes. 6 spokes of 19 10 spokes of 22 These are the standards. You cannot use different size of the spokes there. And then you can use these spokes well together. Then your pulley will get formed here. Okay. So this is regarding the basics of flat plate. Next class, I am going to cover actual design, selection process, and design of your flat belt drive with university problem. If you have any difficulty or any query, you can ask, unmute, and you can ask the query.